Right now, I mean, at this very second, there are millions of people lining up to purchase a mind-altering
Yeah,
substance.
absolutely millions. Yeah.
Right. And it's one that, like, directly manipulates their central nervous system.
Mhm.
It's a compound so deeply embedded in the fabric of human commerce that, honestly, without it, the global economy would probably grind to a halt in, what, 48 hours?
Oh, easily. Maybe less.
Yeah, probably less. But the thing is, when I say that, you aren't picturing, a sterile pharmacy or some windowless clinic.
Right, you're picturing a cafe.
Exactly. You're picturing the hiss of an espresso machine, the clatter of ceramic mugs, and that like amazing smell of roasted
The
beans.
great smell.
It is. But I want you to look at the mug you might literally be holding right now. We don't view that dark liquid as a biological intervention.
Yeah.
We view it as a Tuesday morning.
Yeah, it's just breakfast.
Right. So welcome to the deep dive. Our mission today is unpacking a really fascinating piece of research titled The Caffeine Paradox: Decoding the World's Most Popular Drug.
And it really is a paradox.
It is. And the central question we are putting under the microscope today is caffeine actually a drug? And more importantly, why the answer to that question fundamentally changes how we view our own daily habits.
Yeah, and the sources we're analyzing today, they they force a fairly uncomfortable collision, I would say,
Mm.
between our societal rituals and, well, hard biological realities.
Uncomfortable is definitely the word.
Right. But the goal here isn't to, like, demonize your morning brew. The goal is to strip away that cozy coffee shop aesthetic and look at the actual
It's
pharmacology.
the actual molecule.
Exactly. The molecules crossing the blood-brain barrier.
Yeah.
Because when a substance is ubiquitous enough, its biological reality it becomes entirely obscured by social normalization.
Yeah, we call it a beverage. We treat it like I don't know, a food group.
Right, right.
But think about the cup of coffee or tea you might be holding right now. Do you consider it a biological intervention? Okay, let's unpack this.
So if you look at a morning coffee shop line through a strictly clinical
Which
lens,
is a wild way to look at it, by the way.
it is. But if you do, what you are actually witnessing is a a socially sanctioned, highly unregulated drug dispensary.
Wow. Yeah, when you phrase it like that.
Right. You have a dozen people shifting their weight, staring blankly at their phones, and they are seeking a very specific pharmacological boost to jumpstart their central nervous system.
But nobody in that line feels like they are, waiting for a drug administration. They just feel like they're waiting for a latte.
Exactly. And the researchers term this the caffeine paradox.
Mm.
It's this phenomenon where the staggering scale of everyday social use creates a sort of collective amnesia about the substance's biological classification.
A collective amnesia. I like that.
Yeah, because culturally, we define the word drug using criteria that have absolutely nothing to do with pharmacology.
Wait, what do you mean by that?
Well, society categorizes a substance as a drug based on legal restrictions or social stigma or, whether it's prescribed in a clinical setting.
Oh, right. Like if it comes in an orange plastic bottle with a childproof cap, we respect it as a drug.
Exactly.
Yeah.
And if it's sold out of the trunk of a car, we fear it as a drug. But caffeine is openly consumed across literally all age groups.
Yeah, we give it to teenagers in frappuccinos.
We do. It's celebrated in our media,
Yeah.
and it's deeply tied to our concepts of productivity. Therefore, the brain categorizes it as a ritual or a beverage, completely ignoring its actual mechanism of action.
I mean, I struggle a little bit with the nomenclature here, though. Calling coffee a drug feels a bit like, I don't know, calling a tomato a fruit.
Okay, I see where you're going with it.
Like, it's technically scientifically true based on the biological definitions, but if you chop up a tomato and put it in a fruit salad, people are going to look at you funny. You ruin the picnic.
That is a very fair point.
Right. If it's truly a drug, why don't we view baristas as pharmacists? There's no medical consultation before someone hands over a massive iced cold brew.
The tomato analogy highlights the fiction between taxonomy and culture perfectly. I mean, culinary tradition completely overrides botanical reality in the kitchen.
Exactly.
But the danger of the caffeine paradox, and the reason the medical community is increasingly focused on this, is that when culinary tradition overrides pharmacological reality in the human body, the results can be dangerous.
Yeah, because the body doesn't care about the culinary tradition.
Exactly. The social practice dictates that caffeine is just a drink, but your physiology doesn't care about social practices. It only responds to the chemical intervention.
So the fact that there isn't a pharmacist behind the counter is just an illusion.
Right. The lack of a pharmacist barista is an economic artifact, not a medical one. And this cultural blind spot profoundly shapes patient behavior.
Because if a person doesn't internalize the substance as a drug, they don't apply the basic principles of dosage and caution that they would to, like, literally any other medication.
Precisely. Consider over-the-counter painkillers.
Okay.
If you have a severe tension headache, you might take 2 ibuprofen, right?
Sure.
You would never casually take 12 ibuprofen over the course of an afternoon, simply because they came in a delicious ice-blended caramel-flavored suspension.
Oh, wow. Yeah, that puts it into perspective. That sounds insane when you say it like that.
It does, yet people will casually consume 4, 5, or 6 cups of coffee, or even those high-octane energy drinks throughout the workday without a second
You'd be
thought.
sipping on it all day,
Yeah. And then when they present to a doctor with unexplained tachycardia,
like a racing heart.
yes, racing heart,
Mm?
or chronic insomnia, severe gastrointestinal distress, or generalized anxiety disorders,
Mm.
they rarely mention their caffeine intake.
Because they just think of it as their breakfast drink.
Exactly. They genuinely do not connect the 600 milligrams of a psychoactive stimulant they consumed to their racing heart.
Yeah.
The cultural acceptance creates a massive diagnostic blind spot.
So the physician is sitting there trying to solve a medical mystery, completely unaware that the patient is basically self-administering massive doses of a central nervous system stimulant every single day.
Exactly.
And I suspect part of the reason people give it such a free pass, aside from the fact that it tastes great and helps us hit deadlines, is the origin story.
The origin story. Oh, you mean the plant aspect?
Yeah. The sources spend a significant amount of time dismantling the natural stimulant fallacy. Coffee comes from a bean, tea comes from a leaf, yerba mate is a plant.
Right.
It feels inherently wholesome because it basically comes out of the dirt.
Yeah, but that natural equals benign fallacy is one of the most pervasive and medically frustrating misunderstandings in human health.
Really? Just because it's natural doesn't mean it's safe.
Not at all. The biological origin of a substance, whether it was synthesized in a sterile laboratory or, harvested from a sun-drenched hillside in Colombia, has absolutely zero bearing on its pharmacological potency.
I mean, we do tend to conveniently forget that nature is basically an ongoing chemical warfare zone. Hemlock is natural. Arsenic is natural.
Asbestos is natural.
Right, asbestos.
And, plants do not produce caffeine as some generous gift to help primates stay awake during morning meetings.
That's hilarious. But wait, why do they produce it then?
Evolutionarily speaking, plants synthesize complex alkaloids, like caffeine, primarily as defense mechanisms. Caffeine is actually a highly effective, naturally occurring pesticide.
Wait, really? It's a pesticide?
Yes, when an insect attempts to feed on the leaves or seeds of a coffee plant, it ingests the caffeine. And in the insect's nervous system, caffeine acts as a powerful neurotoxin.
Oh my God, a neurotoxin.
Yeah, it inhibits an enzyme called phosphodiesterase.
Okay, and what does that do to the bug?
It leads to a massive, uncontrolled buildup of cyclic AMP in their cells. The insect's motor neurons just fire relentlessly.
Yeah.
They experience total paralysis, an inability to feed, and eventually death from neurological overstimulation.
So we are essentially harvesting insect neurotoxin, roasting it, and drinking it to finish our spreadsheets. That is a wild reframing.
It really is, isn't it?
But wait, humans have been consuming these specific natural stimulants for centuries across different cultures. Doesn't natural, in this case at least, mean our bodies are evolutionarily adapted to handle it without much risk?
What's fascinating here is that adaptation doesn't mean immunity to the effects.
Ray, break that down for me.
We survive the encounter because of hepatic metabolism, not because our nervous systems are somehow immune to the drug.
Hepatic metabolism.
So our livers.
Exactly. The human liver has developed the enzymatic machinery to break down the caffeine molecule and clear it from the body before it reaches lethal toxicity.
But that doesn't mean it's not affecting us while it's in there. Right. Adaptation is not the same as immunity. The fact that we don't die like the insects doesn't negate the profound alteration of our brain chemistry, while the drug is actively circulating in our bloodstream.
So we process the substance, but we still absorb the full force of the pharmacological intervention.
Exactly. We are just big enough, and our livers are good enough to survive the pesticide.
Which means we need to look incredibly closely at that intervention. We keep using the term psychoactive stimulant, Let's put the abstract concepts aside and walk through the literal biological mechanics.
I think that's a great idea.
What is actually happening in the brain of the listener who just took a sip of their morning coffee? Because the sources draw a very hard line between the concept of energy and what caffeine actually provides.
And that distinction is critical. Medically, a psychoactive stimulant is defined as any substance that crosses the blood-brain barrier and actively alters neurotransmission, mood, and consciousness. The confusion arises from our everyday vocabulary. We say a calorie gives us energy, and we say a cup of coffee gives us energy. But biologically, those are two entirely different pathways.
Right, because caloric energy is actual tangible fuel. You eat a banana, your digestive system breaks down the carbohydrates into glucose, right?
Yes.
And the glucose enters your cells, and the mitochondria convert it into ATP, adenosine triphosphate. That is the actual molecular currency of energy in the human body.
Perfectly said. But caffeine contains 0 functional calories.
None at all.
It provides absolutely no fuel to the cellular engine. Instead of providing fuel, it operates through a mechanism called competitive antagonism.
Competitive antagonism. Okay, sounds intense. How does that work?
To understand it, we have to look at what happens to that ATP you just mentioned. As your brain cells fire and do the heavy lifting of keeping you alive, thinking, and moving throughout the day, they burn through ATP.
Makes sense.
When ATP is broken down for energy, it leaves behind a byproduct molecule called adenosine.
Here's where it gets really interesting. So adenosine is basically the biological exhaust from the engine running.
Yes, that's a brilliant way to put it. It's the exhaust. And the brain closely monitors the accumulation of this exhaust.
It's tracking it all day.
Exactly. Throughout the day, adenosine builds up in the basal forebrain. As it accumulates, it binds to highly specific, custom-shaped receptors on the surface of your neurons, primarily the A1 and A2A receptors.
So the exhaust is locking into specific slots.
Right. And when adenosine docks into these receptors, it initiates a cascading chemical signal that depresses central nervous system activity.
It slows us down.
It slows down the firing of nerve cells, dilates blood vessels to increase oxygen flow for repair, and physically induces that heavy, drowsy feeling of sleep pressure.
So it is literally the brain's internal accounting system saying, we have burned a lot of fuel, the exhaust is piling up, it is time to shut down for maintenance.
Exactly. And caffeine essentially hacks this accounting system. The molecular shape of caffeine, its physical three-dimensional structure, is startlingly similar to the adenosine molecule.
Like they look the same to the brain.
Yes. To the brain's receptors, they look like identical twins. They are similar enough to fit into the lock, but different enough that they don't turn the key.
Oh, wow.
When you drink your coffee, the caffeine molecules flood across the blood-brain barrier and wedge themselves perfectly into those adenosine receptors.
But because it is caffeine and not adenosine, it does not trigger the cellular slowdown message.
Right, it just parks there, occupying the space. It acts as a biochemical blockade.
So it's not actually filling up the gas tank. It's more like putting a piece of black tape over the brain's low fuel light. You aren't giving the body real energy. You're just tricking the nervous system into ignoring the exhaustion.
That is the exact perfect analogy. The actual adenosine, the real fatigue signals, are still being produced.
The exhaust is still building up.
The exhaust is still building up. But it has nowhere to dock. The message is totally blocked. The brain is effectively blindfolded to its own exhaustion.
And this is where the stimulant effect kicks into high gear, right?
Yes. Because the brain's receptors are suddenly devoid of normal adenosine signaling, the pituitary gland registers this lack of fatigue as a potential emergency.
It's like, wait, we're not tired. Something must be chasing us.
Exactly. It interprets the sudden drop in adenosine signaling as, we must be wide awake for a reason, there must be a threat. So the pituitary gland sends a signal to the adrenal glands, which sit just above your kidneys.
And what do?
They dump adrenaline and cortisol into your bloodstream.
This is the cascade. You drink the coffee, the receptors are blocked, the pituitary panics, the adrenaline floods the system. And that adrenaline triggers the physical feelings we associate with the drug.
Yes. Your pupils dilate to take in more light, your airways open up, your heart rate accelerates to pump more oxygen to your muscles.
Which gives you the jitters if you have too much.
Right. Your liver also releases stored glycogen into the bloodstream to provide an immediate burst of actual glucose fuel for a fight-or-flight response. You have chemically stimulated the entire nervous system into a state of heightened survival-level alertness.
It fundamentally rewrites our understanding of waking up. Like we just said with the car analogy, you haven't added a single drop of actual fuel to the car. You've just tricked the internal computer into ignoring the exhaustion.
The engine is still running on fumes, but the driver feels invincible.
Yeah. You are running on borrowed energy. The biological debt is still accumulating in the background. The adenosine is literally piling up outside the receptors, waiting for the caffeine to clear out.
You're just temporarily deaf to the demands of your own physiology.
If we pull the camera back and look at the macro scale, the implications of that mechanism are staggering.
Oh, absolutely.
We have engineered a modern global society where a vast majority of the workforce is operating under the influence of a competitive antagonist just to meet the baseline requirements of daily productivity.
It's incredible when you think about it.
It really is. We have constructed entire industries, from finance to healthcare to logistics, that implicitly demand human beings tape over their biological warning lights every single morning.
It is a structural reliance on a pharmacological intervention.
Right.
If caffeine were removed from the global supply chain tomorrow, the sudden, unblocked flood of adenosine in billions of human brains would cause an immediate catastrophic drop in cognitive function, reaction time, and raw economic output.
Everyone would just crash simultaneously.
We are medicating ourselves en masse to adapt to the unnatural speed and duration of modern labor.
But, what happens when you ignore that low fuel light too long and keep applying tape? The body can't run with the warning lights taped over forever.
No, the engine eventually starts to smoke.
Which transitions us perfectly into the practical safety of this drug, the realities of modern dosing, and the biological differences between individuals.
Yes, dosing is everything.
Because taping over the light with a mild cup of tea is one thing, but taping over the light with a modern, highly concentrated energy drink is a completely different biological event. The sources emphasize that because caffeine is a psychoactive drug, everything hinges on the dose.
In pharmacology, the ancient adage always holds true. The dose makes the poison, and the dose makes the medicine.
Right.
A moderate dose of caffeine, such as a standard 8-ounce cup of drip coffee, which contains roughly 80 to 100 milligrams, might block just enough adenosine receptors to provide a gentle lift in focus and alertness.
It's manageable.
It triggers a mild adrenaline response that the body can easily manage.
But when we move into massive doses, the central nervous system goes from feeling alert to feeling like it is under active attack.
Exactly. When you introduce 300 or 400 milligrams of caffeine into the system rapidly, you are achieving a near-total blockade of the adenosine receptors.
It's total blockade.
And the resulting adrenaline and cortisol cascade is massive. The central nervous system becomes severely overstimulated.
So what does that actually feel like?
Well, the mild lift in focus spirals into tachycardia, a racing, irregular heartbeat. The increased gastric acid production causes profound gastrointestinal distress.
Ugh, the coffee stomachache.
Right. The motor neurons fire too rapidly, causing physical tremors in the hands. The psychological result is a profound racing anxiety.
You are essentially using a drug to artificially induce the physiological state of a panic attack.
You really are. And this is where the evolution of delivery systems becomes so critical. We are no longer a society that just sips hot, bitter bean water over a morning newspaper.
The aesthetic has changed.
The shift toward energy drinks fundamentally changes the pharmacokinetics, how the drug moves through the body.
Break that down. Why is an energy drink so much worse than a coffee?
Traditional coffee has built-in safety mechanisms. It is hot, which physically limits how quickly you can drink it.
Right, you have to sip it.
It is bitter, which limits how much of it is palatable. The absorption into the bloodstream is relatively gradual over the course of 30 minutes to an hour.
Okay, but energy drinks.
Modern energy drinks are engineered to bypass all of those natural limitations. They are served ice cold, they are carbonated, and they are heavily flavored with artificial sweeteners and masked by massive amount of sugar.
The sugar doesn't just make it taste better, though, right? Doesn't it actually accelerate the drug delivery?
It absolutely does. The combination of cold liquid, carbonation, and simple sugars increases the rate of gastric emptying.
Gastric emptying.
Yes. The liquid moves from the stomach into the small intestine, where the vast majority of caffeine is absorbed incredibly quickly. A person can easily consume a 16-ounce energy drink in under 3 minutes.
Just chug the whole thing.
Exactly. And what they are consuming is a massive payload. These beverages frequently contain 300 milligrams of synthetic caffeine in a single can.
That is the equivalent of downing 3 or 4 cups of coffee simultaneously.
Furthermore, they often include synergistic stimulating compounds.
Like what?
You will see ingredients like guarana extract on the label.
Oh, I've seen that. What is a guarana?
Guarana is a plant whose seeds contain up to 4 times the amount of naturally occurring caffeine as a coffee bean.
4 times.
Yes. Plus, they add taurine and massive doses of B vitamins. The result is a highly concentrated, hyper-rapid pharmacological payload that just shocks the central nervous system.
Okay, let's map this out to a highly relatable real-world scenario for the listener.
Into it.
Imagine it's a Tuesday afternoon, it's 4:00 p.m., you have a massive presentation due tomorrow, and you hit the classic mid-afternoon wall. The adenosine is piling up.
You're crashing.
Exactly. So you walk down to the corner store, grab a brightly colored, aggressively branded energy drink, and chug it at your desk. You crush the deadline, you feel laser focused for 3 hours.
Right.
But then the clock strikes 2:00 a.m., you're lying in bed, the room is dark, your body is physically exhausted, your eyes are burning, but your thoughts are racing at 1,000,000 miles an hour.
Staring at the ceiling.
Yes, your heart is thumping against your ribs, you are experiencing severe sleep disruption. Why is the drug still ruining your life 10 hours later?
That 2:00 a.m. ceiling stare is a perfect lesson in pharmacokinetics, specifically the concept of a drug's half-life.
Half-life. Okay, explain that.
The half-life is the amount of time it takes for the liver to metabolize and clear exactly 50% of the drug from your bloodstream.
Just 50%.
Just 50. In a healthy adult, the average half-life of caffeine is roughly 5 to 6 hours.
So if we run the math on that 4:00 p.m. energy drink,
You consume 300 milligrams at 4:00 p.m. By 10:00 p.m., 6 hours later, your liver has processed half of it. You still have 150 milligrams actively circulating in your blood.
wait, 10:00 p.m. and you still have 150 milligrams? That is more than a full cup of coffee.
Exactly. By 4 a.m., you still have 75 milligrams in your system.
Oh my gosh.
You are attempting to initiate the incredibly delicate, complex neurological process of deep sleep, while a potent psychoactive stimulant is actively blocking your fatigue receptors and triggering adrenaline release.
No wonder you can't sleep.
It fragments your sleep architecture, specifically destroying the deep, slow-wave sleep required for physical restoration.
Why is the dose response so wildly different, though? Because my coworker can drink a double espresso after dinner, like at 8 p.m., and sleep like a baby. But if I look at a green tea afternoon, I'm vibrating with anxiety. Why the disparity?
The disparity is entirely genetic. It comes down to the specific hardware in your liver.
Hardware.
Yeah, the human liver metabolizes caffeine using an enzyme called cytochrome P451A2, commonly abbreviated as CYP1A2.
Pitchy name.
Very. Enzymes are basically molecular scissors. They bind to the caffeine molecule and snip off specific methyl groups, breaking the drug down into smaller, inactive metabolites that can be excreted by the kidneys.
And we don't all have the same scissors.
We all have the enzyme, but the gene that codes for CYP1A2 has different variants in the human population.
Okay.
Some individuals inherit a genetic variant that makes them fast metabolizers. Their liver enzymes are highly efficient, acting like high-speed industrial shredders.
So they chew through the caffeine?
They clear the caffeine from their bloodstream incredibly rapidly.
Right.
Your coworker, who drinks the after-dinner espresso, has the fast metabolizer gene.
Lucky guy.
The drug peaks and is cleared before it can significantly disrupt his sleep architecture.
And for the rest of us who suffer from a single afternoon cup.
You're likely a slow metabolizer. Your genetic variant produces enzymes that work at a much more leisurely pace.
Which means it just sits there.
The caffeine lingers in your system for significantly longer than the average 5 to 6 hour half-life. It continues to block adenosine and stimulate the central nervous system deep into the night, leading to prolonged anxiety and severe sleep disruption.
It is entirely hardware dependent. That's wild.
It really is.
But even if you have the fast metabolizer hardware, your body's reaction to the drug doesn't remain static. The nervous system doesn't just passively accept this daily chemical flood. It is a dynamic living system.
It adapts.
It adapts. And this brings us into the mechanics of everyday use. Tolerance, physical dependence, and the brutal reality of withdrawal. This is where the illusion of the harmless beverage completely shatters.
Oh, entirely. Because the brain is an incredibly sophisticated organ whose primary goal is homeostasis, maintaining a stable, balanced internal environment.
Right.
When you consistently introduce a drug that blocks the adenosine receptors day after day, the brain recognizes that its internal communication system is failing.
It's like, why aren't we getting the fatigue signals?
Exactly. It senses the massive buildup of unbound adenosine and realizes we are constantly overstimulated. Our fatigue signals are not getting through. We need to restore the balance.
If the caffeine is occupying all the existing receptors, how does the brain fix the communication breakdown?
It literally builds more receptors.
Wait, really? It just makes more.
Through a process called neuroplasticity, the brain physically alters its own architecture.
Yeah.
It upregulates the production of adenosine receptors, embedding more of them into the surface of the neurons.
It is essentially building new parking spots for the adenosine to dock into, trying to bypass the caffeine blockade.
That's exactly what it's doing.
That is a staggering biological workaround. But that workaround creates a massive new problem for the person drinking the coffee.
It creates the mechanism of tolerance.
Okay, let's walk through that.
Let's say your baseline dose was 1 cup of coffee.
Hmm.
That 1 cup contained exactly enough caffeine molecules to block your original number of receptors.
Right.
But now, your brain has built a surplus of new receptors.
Yeah.
Tomorrow morning, you drink your single cup of coffee. It blocks the original receptors, but all the new extra receptors are left wide open.
Because you didn't add more caffeine.
Right. The adenosine docks into the new receptors, and you still feel lethargic and tired, despite having your normal dose of the drug.
So, to achieve the original feeling of alertness, you now have to drink 2 cups of coffee to generate enough caffeine molecules to block the new expanded array of receptors.
You are chemically chasing a moving target.
That is so frustrating.
And that is the clinical definition of pharmacological tolerance. Your body requires an increasingly higher dose of the substance to achieve the original physiological effect.
Wow.
And this upregulation of receptors leads directly to physical dependence. Because your brain has physically restructured itself to accommodate the daily influx of the drug, it now relies on the presence of that drug just to maintain baseline functioning.
And when the drug suddenly isn't there, that is the crash. Let's explore the withdrawal, because the sources provide a brutally clear picture of what happens when a dependent brain is suddenly deprived of its chemical crutch.
Consider the biological state of a dependent brain. It has an artificially high number of adenosine receptors, right?
Right.
And it relies on caffeine to block a significant portion of them to keep you awake. If you abruptly cease your caffeine intake, the brain is left with an abundance of open receptors and a massive backlog of adenosine.
And without the caffeine blockade,
An overwhelming flood of adenosine binds to all those receptors simultaneously.
the dam breaks.
The nervous system crashes. The result is an immediate crushing wave of fatigue and lethargy.
But the neurological effects go beyond mere tiredness, right?
They do. Remember that adenosine doesn't just signal sleepiness, it also acts as a powerful vasodilator.
Vasodilator, meaning it opens up the blood vessels.
Yes. It relaxes the smooth muscles in the walls of your blood vessels, causing them to widen. Caffeine, conversely, is a vasoconstrictor. It narrows the blood vessels in the brain.
So the dependent brain is used to constricted blood vessels when the caffeine is removed.
The massive rush of adenosine causes profound, rapid vasodilation. The blood vessels in the brain expand quickly, significantly increasing blood flow.
Okay.
This sudden increase in volume stretches the meninges, the sensitive membrane surrounding the brain, and increases intracranial pressure.
Which results in the infamous weekend headache. This is perhaps the most universally experienced yet misunderstood symptom of drug withdrawal on the planet.
Oh, it really is.
People work an exhausting Monday through Friday schedule, waking up at 6:30 a.m. and immediately drinking their coffee. Then Saturday morning arrives.
They want to sleep in.
Right. They decide to sleep in until 9:30 a.m. They wake up with a pounding, debilitating headache, severe brain fog, and intense irritability. And they usually blame it on, like, dehydration or stress or a bad mattress.
They have no idea they're in active drug withdrawal.
None.
The timing is not a coincidence. It perfectly tracks with the half-life of the drug clearing out of their system. They delay their daily dose by 3 hours.
3 hours is all it takes.
For a heavily dependent person, yes. The blood levels of caffeine drop below the threshold necessary to block their artificially expanded network of receptors. The vasodilation occurred, the intracranial pressure spiked, and the physically dependent brain sounded the alarm.
So the pounding head and the terrible mood are not just the psychological disappointment of missing a comforting morning ritual.
Not at all. They are the objective physiological symptoms of a central nervous system in acute distress, because a chemical it physically relies upon is absent.
Okay, if my body relies on this to function normally, and I get physical withdrawal symptoms without it, am I an addict? Is there a medical line between dependence on this drug and addiction as we traditionally understand it?
This raises an important question, and it is one of the most critical distinctions in addiction medicine.
Okay, I'm ready.
The sources draw a very clear boundary. The short answer is no. A physical dependence on caffeine does not mean you suffer from addiction.
Okay, phew.
The terms are often conflated in casual conversation, but clinically, they describe two entirely different phenomena. Physical dependence is a purely biological cellular adaptation.
It's the cells changing.
It is the tolerance and withdrawal cycle we just described. A patient can become physically dependent on a wide variety of non-addictive medications. Certain blood pressure drugs, asthma medications, or antidepressants will cause severe physical withdrawal if stopped abruptly.
The cells adapt, but the cells adapting isn't enough to define addiction.
Correct. Addiction is fundamentally defined by behavior, specifically destructive behavior driven by a hijacked reward system.
Destructive behavior.
Addiction is categorized as a chronic, relapsing brain disease characterized by compulsive drug seeking and use, despite severe harmful consequences to the individual's life.
The despite harmful consequences part seems to be the crucial dividing line.
It is the defining feature. Highly addictive drugs like opioids, cocaine, or amphetamines flood the brain's mesolimbic dopamine pathway, particularly a region called the nucleus accumbens.
Which is the reward center.
Yes, they create a massive artificial surge of dopamine that hijacks the brain's survival programming, making the acquisition of the drug feel more important than food, water, or social bonds.
Wow.
If someone is suffering from a severe substance use disorder involving those drugs, they might drain their life savings, destroy their marriage, lose their career, or engage in highly dangerous, illegal behaviors just to secure their next dose. Their moral and social frameworks are dismantled by the chemical drive.
But caffeine doesn't trigger that dopaminergic hijacking. It blocks adenosine, but it doesn't fundamentally rewire the survival hierarchy.
Exactly. Caffeine provides a mild dopamine bump, but it is nowhere near the magnitude required to override your executive function.
Right.
If you miss your morning coffee, you will experience a headache. You will be lethargic. You might be uncharacteristically short-tempered with your coworkers or your family.
Guilty.
But you are not going to rob a convenience store, empty your child's college fund, or pawn your television to secure a cappuccino.
No, probably not.
The drive to consume the drug is strong, largely to stave off the discomfort of withdrawal, but it does not compel destructive antisocial behavior.
That distinction brings immense clarity. It is a drug that causes physical dependence, but it doesn't dismantle society. Which leads us to the final major theme of the research, the regulatory context.
This is a really interesting area.
So what does this all mean? We've established that caffeine is a potent psychoactive stimulant. It alters brain chemistry, it causes physical dependence, and at high doses, especially in energy drinks, it can cause severe cardiac and neurological distress.
Yes.
So why does it sit in a completely different regulatory universe than almost every other drug with a similar physiological profile? Did caffeine just get a regulatory free pass because it fueled the Industrial Revolution?
Well, when regulatory bodies like the FDA classify substances, determining what requires a prescription, what gets scheduled as a controlled substance, and what can be sold over the counter, they primarily evaluate the overall harm profile.
The harm profile.
They weigh the potential for severe abuse, catastrophic health risks, and societal damage. Because caffeine does not trigger the destructive behavioral patterns of addiction, and because fatal overdoses from traditional coffee consumption are practically impossible due to the volume of liquid required, it escapes the strict regulatory net of controlled substances.
But the sources suggest there is a growing tension, a regulatory blind spot, particularly concerning the modern delivery systems we talked about earlier.
Yes, the energy drinks.
The rules that make sense for a cup of drip coffee seem wholly inadequate for a brightly colored, fruit-flavored can containing 300 milligrams of synthetic caffeine and guarana.
The regulatory framework is struggling to keep pace with the pharmacokinetics of the modern beverage industry.
It really is.
A cup of coffee is self-limiting. The heat, the bitterness, and the volume protect the consumer. You will likely experience severe nausea and stop drinking long before you reach a cardiotoxic dose.
Your body stops you?
But highly concentrated, heavily sweetened energy drinks strip away all those natural safety mechanisms. A teenager can easily chug 2 or 3 of these cans back to back in a matter of minutes.
And that is a massive influx of a psychoactive stimulant into a developing cardiovascular and neurological system.
And there are real-world consequences to that rapid absorption. We are seeing documented, peer-reviewed cases of severe cardiac arrhythmias, panic attacks requiring hospitalization, and other acute toxicological emergencies resulting from the rapid overconsumption of these modern delivery systems.
That is terrifying.
This shifting harm profile is why the regulatory debate is heating up. Some European nations have already implemented age restrictions, banning the sale of high-dose energy drinks to minors.
Which makes sense.
Medical professionals are increasingly advocating for prominent, explicit warning labels detailing the risks of high-dose consumption, similar to the warnings on alcohol or tobacco.
Which raises an incredibly fascinating thought experiment. Did it really just get grandfathered in because of its history? Consider the historical context. Caffeine fundamentally fueled the transition into the modern world.
It did. Before coffee and tea became universally accessible in Europe, the primary daily beverage for the working class was weak beer or ale, because the water supply was riddled with waterborne pathogens.
Right, boiling the water for brewing made it safe.
The result was a European workforce that was essentially mildly inebriated from sunrise to sunset.
Which was manageable when labor was primarily agricultural and tied to the natural rhythms of the sun. But the Industrial Revolution fundamentally changed the requirements of human labor.
Exactly. You can't operate a spinning jenny or a steam-powered loom if you are slightly drunk.
No.
The new economy required precision, focus, and the ability to operate heavy machinery indoors for 14 hours a day, entirely disconnected from the natural human circadian rhythm.
And caffeine was the pharmacological key that unlocked the Industrial Revolution. It replaced a central nervous system depressant with a central nervous system stimulant.
It suppressed the biological need for sleep, improved focus on repetitive tasks, and allowed human beings to physically synchronize with the relentless pace of the machines and the factory clocks, rather than the rising and setting of the sun.
Modern industrial capitalism was literally built on the back of caffeine's ability to block adenosine.
It really was.
And that profound economic reliance acts as an impenetrable shield against strict regulation. The global economy cannot afford for the workforce to experience the collective withdrawal crash.
No, it would be devastating.
But let's run the thought experiment. What if that history didn't exist? What if a pharmaceutical laboratory synthesized caffeine for the very first time tomorrow?
Oh, that's a great question.
If a new drug was discovered tomorrow that caused physical dependence and sleep disruption in billions of people, a brand new drug that alters brain chemistry, causes physical dependence in millions, triggers severe anxiety at higher doses, fragments deep sleep architecture, and results in debilitating withdrawal headaches if a daily dose is missed. Would we leave it totally unregulated? Would the FDA let us sell it in brightly colored cans to teenagers at gas stations?
Almost certainly not. If caffeine were presented to the FDA as a novel compound tomorrow, its pharmacological profile would likely require it to be classified as a prescription medication, or at the bare minimum, it would be heavily restricted behind the pharmacy counter with prominent black box warning labels detailing the risks of tolerance, withdrawal, and cardiovascular stress.
Wow.
The fact that we hand it to each other in paper cups with our names misspelled on them is a testament to the power of cultural normalization over scientific reality. It brings us right back to the core caffeine paradox. We accept the pharmacological intervention because we adore the ritual, and our entire economic structure demands the results.
It is the ultimate paradox. This has been a truly illuminating journey through the research today.
This has been great to talk about.
We started by examining the cultural blind spot, how the smell of roasted beans and the aesthetic of the cafe completely mask the reality of a global drug dispensary. We dismantled the natural fallacy, exploring how plants evolve these complex alkaloids as neurotoxins for pest control, not as productivity aids for humans.
We dove deep into the biochemical mechanics, mapping exactly how caffeine molecules operate as competitive antagonists. We saw how they perfectly mimic the shape of adenosine, wedging into the receptors, blocking the brain's internal fatigue signals, and triggering the pituitary gland to launch a cascade of adrenaline and cortisol.
We looked at the critical impact of dosage and pharmacokinetics, drawing a hard line between the slow absorption of traditional coffee and the hyper-rapid, highly concentrated shock delivered by modern energy drinks.
We explored the genetic lottery of the CYP1A2 liver enzyme that determines your half-life. We faced the biological reality of neuroplasticity, how the brain builds new receptors, leading directly to tolerance, physical dependence, and the brutal vasodilation of the weekend withdrawal headache.
And finally, we unpacked the regulatory divide, understanding how caffeine's lack of addictive, destructive behavioral hijacking, combined with its foundational role in the Industrial Revolution, grants it a permanent, unregulated pass in our society. So, addressing the core quote of our mission today, medically, biologically, and undeniably, caffeine is a drug.
If we connect this to the bigger picture, understanding caffeine as a drug isn't about fear. It isn't about fear-mongering or guilt. It's fundamentally about medical literacy.
Being informed?
Yes, it is about shifting from passive consumption to informed consent regarding your own neurochemistry. When you fully grasp the mechanisms of competitive antagonism and half-lives, you gain the power to respect the substance.
Right.
You can strategically time your doses to protect your vital deep sleep architecture. You can recognize the creeping onset of tolerance and deliberately taper down to allow your receptors to reset. You can actively manage your nervous system rather than letting the drug dictate your physiological baseline.
It's about moving from autopilot to intentionality. Stop taping over the warning light without understanding why it's flashing. I want to leave you with a final, somewhat provocative thought to mull over.
Go for it.
We have spent this entire deep dive dissecting the biology, the history, and the culture of this incredible molecule. Tomorrow morning, when you inevitably reach for that mug, or when you pop the tab on that cold can, take just one deliberate second to pause. Look at the liquid. And ask yourself a very honest question. Are you drinking it right now because you genuinely, truly enjoy the culinary ritual and the taste? Or are you drinking it because your nervous system has quietly, physically restructured itself to demand its daily medication, just so you can tolerate the unnatural speed of modern life? Think about it.
That's a powerful thought to end on.
Thank you so much for joining us on this deep dive. It is always a profound pleasure unpacking these complex realities with you. Until next time, stay deeply curious, respect your receptors, and maybe try to get a little extra sleep. See you next time.